The modern periodic table has 18 vertical columns, known as groups, and 7 horizontal rows, known as periods. Take a look at the group 1 of the modern periodic table. You will notice that all these elements contain the same number of valence electrons. Similarly, you will find that elements present in any one group have the same number of valence electrons. For example, elements fluorine and chlorine belong to group 17. Both of them have 7 valence electrons in their outermost shells. Hence, we can say that groups in the periodic table signify an identical outer shell electronic configuration. On the other hand, the number of shells increases as we go down the group. There is an anomaly when it comes to the position of hydrogen because it can be placed in group 1 or group 17 in the first period. Take a look at the long form of the periodic table and observe the elements lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Observe that these elements do not have the same number of valence electrons, but they contain the same number of shells. You will also observe that the number of valence shell electrons increases by 1 unit as the atomic number increases by 1 unit on moving from left to the right in a period. Hence, we can say that atoms of different elements with the same number of occupied shells are placed in the same period. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon belong to the third period of the modern periodic table, since the electrons in the atoms of these elements are filled in the K, L and M shells. The number of elements in a particular period can be explained based on how electrons are filled into various shells. The maximum number of electrons that can be accommodated in a single shell depends on the formula 2n square, where n is the number of the given shell from the nucleus. For example, the K shell can accommodate 2 electrons and hence the first period has 2 elements. The L shell can accommodate 8 electrons and hence the second period has 8 elements. The M shell can accommodate 18 electrons, but the outermost shell can have only 8 electrons, and so the third period also has only 8 elements. The position of an element in the periodic table tells us about its chemical reactivity. Valence electrons determine the kind and the number of bonds formed by an element. Thus, we can say that Mendeleev's choice of formulae of compounds as the basis for deciding the position of an element in his periodic table was a good one. Thank you.